Okay, hey, hi, welcome to the next panel discussion. This is about accelerating learning, if I could speak, with educational neurogaming. My name's Dan Tynan. I write the Modern Family column for Yahoo Tech. It unfortunately has nothing to do with Sofia Vergara. But last year, I wrote a story about the Muse headset and about brain-computer interfaces, in which I interviewed Zach and talked to some people in the field and kind of got hooked. And that's kind of why I'm here now. But I'd be willing to bet I probably know less about educational neurogaming than anyone in this room, which is why we have this esteemed panel. And rather than mangle their names and their bios, I'm going to let everyone introduce themselves, tell us all who they are and why they're here. So who are you guys, and why are you here?
So I'm Alan Gershenfeld. I guess very briefly, my background was originally movies in Hollywood and China. Then I helped rebuild Activision, the game company, from the early 90s to 2000, a lot of big commercial games, and then became chairman of a nonprofit called Games for Change, looking to harness the power of games for learning, health, social impact, and was tracking a lot of funding coming from foundations, government agencies, but not necessarily seeing it compete in the consumer space or replace scope and sequence in the classroom. So I co-founded a company called Eline Media to help close that gap.
I'm Amy Kruse. I'm the Vice President of Innovation at Intific, which is actually about a year now has been acquired by the Qubic Corporation, so a much larger corporation. My background is a PhD in neuroscience. I was a program manager at DARPA from 2005 to 2010, and then joined Intific essentially to take the work that we had done in the defense space and actually move it into the neuroscience and education and social media space. So really trying to expand from kind of maybe the other direction, right? Take people who had traditionally worked in the government space and actually put the commercial aspect into those platforms, and it's been very successful.
Hi, I'm Peter Hartzbeck, founder and CEO of iMotions. In iMotions, we built a platform that can actually synchronize a lot of biosensors with facial expressions and eye tracking. We've had a lot of discussions about that, creating these closed loops from Adam's keynote. That's a platform that we have actually built that's being used in everything from education into medical applications, diagnosis of diseases, and so on. We're based at MIT, and the reason we're here is because, and we have actually been here for the last 3 years since Zach started this conference, that we really see so many evolving new sensors, and really to understand all that multimodal approach and create these loops where you can build games that can really enhance the learning and so on. That's really why we're here, and try to help to use it for example, diagnosis of diseases and stuff like that.
Perfect.
Hi, my name is Dhiraj Jeyanandarajan. I am a clinical neurologist. I work in the world of neurophysiology, where we do real-time monitoring of neural parameters during brain and spine surgery, and in short, have 2 small kids and exposure to what's out there in the educational market, and some exposure to earlier versions of this conference about 2 years ago, just seeing the development in this space. Had started the development of an educational video game that uses the same technology to dynamically alter the content presentation to the individual, and we founded this company called Qneuro, which is an educational software company that uses that technology.
Terrific. Thank you, guys. Welcome. So let's start by defining some terms. Neurogaming for education, or educational neurogaming. What does it mean? I mean, what are we really talking about? Who wants to jump in?
So, I mean, I can chime in there, because our Qneuro itself is an educational gaming software that uses the neural gaming aspect of it. So it's a game, it's a educational video game, but the neural aspect is we are recording EEG, so we're monitoring their cognitive state in real time. And we're using that combined with certain parameters from the gameplay itself. And in combination, we're using that information to create a highly individualized learning experience. So we're basically augmenting that learning experience and creating a more efficient path of learning for any particular individual.
And one of the things that I keep thinking about when we keep talking about educational neurogaming, and maybe it's why I didn't jump on it right away, was it's actually a little bit narrow. I do think that it's almost like I'd like to add the word training to that, or add a word that kind of expanded it a little bit, because I do think when we start talking about educational neurogaming, thoughts immediately go to sort of a student or maybe a child population, and I actually think it's a little bit bigger. But I absolutely agree that the piece that's the neurogaming part is really kind of including the brain or the physiology or the biophysiology kind of in real time, not just for the monitoring, but that closed loop aspect. And I think that's where we're moving the field, and I think that's what we've seen some interest. Obviously, it's still in its infancy in terms of the application of that closed loop and what the best way of going about that is, because there's a lot of options, right? As many brain signals and metrics and algorithms that we can come up with. So, but I do think about it maybe just a tiny bit bigger from the definition perspective.
So maybe learning as opposed to educational.
Sure.
Right?
Yeah, so there's a lot, of course, also things like self-training, that you can use this system to train yourself. That's also kind of an education. I mean, we see a huge, wide range of applications that use games to really do this. So going from, trying to get kids to use the games, I get a little bit in your space as well, to give them a comfortable environment where you basically do a lot of tasks for them, where you can then see if they actually have autism. The same with ADHD, schizophrenia, where you can also, you have a problem really exposing an emotion, so you can sit in front of these systems and actually help train yourself. So self-training is also one aspect that falls under this, I would say.
We have an interesting project with Daphne Beverley, who spoke at the SCONS conference a few days ago with NSF and Sesame Workshop, building on her and some other colleagues' research on how 3D action games, rewire your brain for certain benefits in the learning and health spheres. And we're exploring if we can isolate the mechanics in the 3D games that they test, like Call of Duty, which are not appropriate for young kids. But you can isolate things like real-time statistical inference under pressure, keep the mechanics, take out the violence, put it in an age-appropriate fiction, still see if you get the neurological benefits. But the really interesting thing that has emerged is just the notion that a child can see what's happening in their brain, learn their brain can get unstuck, and that their brain can be changed, I think, is transformative. And using it as a gateway to inspire and fire the imagination around the brain is yet another learning benefit that can come of it. Because when a child is motivated, when a child is fascinated, when a child is engaged, you have a much more open mind to improve the mind.
Right. Right, and I think that motivation and engagement aspect is one of the reasons why we keep coming back to gaming, right? Because that is a mechanism into sort of those motivation parts of a child's life, or even as we go into adulthood. I mean, sort of everybody wants to level up, right? So,
Terrific. So, but is this still essentially a research project? Are there examples of this out there in the wild? Are people doing this today?
I mean, again, we're not out there yet. Projected release date is December of this year, but we are exactly in this space of neuroeducation, and we are, it's real-time neural monitoring while they're engaging in this, and it's a feedback loop that actively, dynamically changes the game itself. So yes, I think we're there. I think we're actually there, and we've gotten very positive feedback from educators and from students and kids alike who have used it in our closed lab environment. So we're excited. We're excited that we're kind of on the cusp of this.
It really depends also how many modalities you use. I mean, like now we work with both EEG, ECG, EMG, face expressions, and eye tracking. So of course, a lot of these devices can still be a bit clunky. So those are still in a research, area or with a research perspective. But what is going to happen now, and what we're seeing is that all of these devices, we could see the new emotive one, for example, here, that you have seen out here, they get much smaller, easier to put on. And of course, what is happening is that what you can get from the really high-end headsets are really evolving a lot, but I think we are still a little bit away from having a multimodal concept that really scales out into consumer markets. But we do see it scaling, however, in the research field where we can set up hundreds of machines and really collect a lot of data and have these feedback loops coming in and merge across sites. So I mean, it is still pretty scalable, but you know, I mean, obviously, if you have to spend 15 minutes put on a EEG headset, it's not something that everybody would sit and do at home, putting gel on the hair and so on, right?
Well, and I think part of that moving into the commercial space and getting out there, and I you know, personally, this is one of the things that I talk about when I talk to people in this space is we really do have to show that it adds value. And I think when you show that adding the neuroscience piece and adding sort of this extra layer, closing the loop has value, I think you'll see that accelerate quite a bit into you know, the application space and the commercial application space. So.
Perfect.
There are very different markets, very different demographics, very different psychographics. We separate our lines of business. We have a consumer line of business for games that can fire the imagination, open new worlds, but we are competing for youth and young adult discretionary time with everything out there. The bar is very high. It's a different set of platforms. It's a different set of business models, distribution. We're also in about 15,000 schools with our game-based curriculum, and it's a very different structure. It's a very different design. It's a very different set of processes. And then you have informal learning environments in libraries, museums, after schools, which is yet a different model. So I think one has to optimize their solution and their impact objectives, whether they're learning or health, towards a deep understanding of the channel. Are you replacing scope and sequence in a classroom or in a moderated service environment, or are you competing for discretionary time, either parent purchase or youth purchase?
Perfect. So I believe this is the first time the NeuroGaming conference has talked about education or learning. And so I'm curious to get your take on why we're talking about it now. What has changed in the past year, 18 months in this field that enables us to at least start to talk about it and start to implement it?
Yeah, I can throw something in there. So I think one thing, there's one word that has changed a lot of things over the last couple of years. That's called unity. So really, what has happened is that something that, you know, like military, you know, research centers and so on, maybe spend like 2-3 years of building, you can really basically get down and do in like a very few days or even hours to build small virtual environments where you can basically just build these tasks and really get, you know, the emotional response fed directly into the game and let it change depending on the emotional response. And that's something that we see just like scaling extremely fast now. And you know, like more or less all the kids out there, not a lot of kids in this room, but so you know, when you go to school today, when you're 13 years old, you're already hacking your first game together. So really, like this whole new generation coming, just have so much other possibilities of changing or of building these kind of virtual environments where you can really build it into a learning environment.
Okay, so it's the tools to enable the creation of environments that has been one of the biggest changes in your opinion.
And one other thing that's happening is, of course, that the sensors are becoming smaller. Where we see, of course, that closest to scale and the things that are easier to implement is facial expression analysis. So with the processing power that has happened over the last couple of years, and the millions of dollars that has been invested into building these automatic face expression engines, is really also leaping forward extremely fast. And I mean, this is something that you can do on your phone. It's something you can do like pretty easily just with a normal web camera that runs a frame rate of 30 hertz. So that is also beginning to move things ahead a lot.
I think one of the other things is actually an internal change, sort of how we as individuals think about data about ourselves. And so I think that's an interesting, you know, it's not just the tools, but, you know, if 10 years ago you told somebody you were going to track their brain activity and, you know, they kind of looked at me like, why, you know, why what do I need to, what are you going to tell me? You know, now we're covered with Fitbits and watches and everything else. We're interested in data about ourselves. And I think that internal change has actually driven the matchup with the tools that are available to kind of move us into this space, because it's like, oh, it's possible. Of course it's possible. I've got on my watch. I've got on my thing. You know, I mean, it just makes sense. Whereas when we started this sort of perspective 10 years ago, it didn't quite make the same sense.
So each day you're going to have 10,000 thoughts.
Right. Yeah. Exactly. Okay. Yeah. Or ideas.
In the K-12 education space, and I know there's a bunch of people interested in that space, there's remarkable change happening, and it's not necessarily obvious, but it's going to accelerate. Textbooks are going away, often by law, in most countries. That means the spine of the curriculum is changing. In general, curriculum's becoming unbundled. It's going to be rebundled, in general, mediated in a variety of blended ways through technology. almost every country, almost every minister of education, everywhere wants to cultivate these dispositions of problem solving, critical thinking, the higher order skills. In general, that leads towards inquiry-based blended learning. We're not set up for that, and these are massive pain points. You know, teachers do amazing work adapting curriculums. It's easier to adapt a textbook than technology-mediated, especially if you're going in from virtual worlds to mobile, to traditional lectures, to flipped, where there's help at home or not help at home. So this dislocation is creating unbelievable pain, but incredible opportunity. And any solutions, I mean, what we found, because we're in 15,000 schools, we have no salespeople. I mean, we've disintermediated going directly to teachers and schools, is rigorously reducing friction, understanding the scope and sequence, and letting teachers adopt and adapt. So it's a tricky process, but it's a once-in-a-lifetime opportunity to affect change because of the dislocation.
And I think one of by far the biggest thing from our perspective, that is why we're talking about this today, is cost, right? The cost of these and the accessibility of the neural recording devices has gone down so tremendously. When I was in, I'm not going to date myself by giving a year, but when I was in training, you know, for neurology, and when we were doing EEGs for patients, it's a different type, it's a different grade of EEG machine, but we're not talking of anything under $50,000, right? So now with companies out here like Emotive and Muse and things that are very accessible to the consumer, the price point is something where, you know, if you have a useful enough application for that, which education we believe is a useful enough application for that, you're going to see this in more and more households, which will then in turn lead to economies of scale, which will continue to drive the price down.
Interesting. So that does bring up one of the things I wanted to talk about, which was the challenges. I mean, obviously it's not just educational setting, but people think of this in terms of, you know, our kids, usually. In school classrooms. And you know, Alan talked about some of the challenges, but I wonder if there are other challenges involved with getting from a product that works to something that people actually adopt and use in the classroom.
I think one of the things is, of course, privacy. That's the obvious one, right? I mean, you are, you know, giving away a lot of data that is really from the inside you can't control yourself. And you know, we might all get used to it, but you know, I'm not sure how, you know, well I would like that my phone is measuring my facial expressions all the time and knowing exactly what I'm looking at. So I think definitely that's definitely a barrier for the true scaling. But I also think there's a lot of ways we can implement this. For example, let's say that you go out to it depends on how you measure scaling, right? Because one thing is consumer devices, but I think it won't take many years before we go down to the doctor. We sit in front of a high-end eye-tracking screen that has face expressions, and maybe you just wear one little arm bracelet here. You see a battery of stimuli, and then you basically say, okay, you know what, you should actually be tested a little bit more thoroughly for this. So I don't think it will be long before we have these kind of screening devices that can actually be scaled out a lot. But that's, of course, not consumer products.
Right.
And I think one other point that was touched on earlier was you have to show that it's effective, right? Why would a school actually adopt this technology and use this technology over existing methods? You have to show that there's an actual benefit to using it. We think that there is, and we are, you know, fairly aggressive about trying to be you know, get independent verification and do real studies that will show that an A to B comparison that there is a benefit to using this technology versus not using that technology.
And that's expensive, right? I mean, there's a cost associated with that, which is, I think, one of the challenges in this space is, you know, there's certainly, I mean, anybody can make an educational game and put it on the App Store, right? I mean, that doesn't mean it's an educational game, but I'm saying in terms of its label. And so I think, you know, here at the conference, we're talking about things that have clinical value, maybe things that have educational value or cognitive value or training value, and then maybe things that are very, very casual, not really what we're talking about here, but certainly know that there's a huge market for that. And so I do think it is in that space, in that sort of middle space of showing value. I don't need it to quite be a clinical trial, right, to use in an educational setting, but there has to be some verification and data behind it. A lot of times, and my guess is, Alan, this is why you guys have had such luck going directly to the teachers, right, is because they know their classes and they know how their classrooms operate, and they can kind of tie into that a lot faster than if you try to approach it from a district-wide or a statewide approach.
Our transition from going direct to teachers to now doing district sales is very different, because when a teacher is asked to do something that they don't particularly want to do or haven't been trained to do or don't have a classroom set up to do, it creates a lot of pain. There's another subtle factor with these communities of practice, because I work in a number of community practice, whether it's the bits and atoms with the 3D printers or the virtual worlds or NeuroGaming. Understanding the enabling ecosystem where a number of providers can thrive. So the idea of things not one solution scaling, but propagating. So are there platforms where multiple people can build on and crack some of the hard stuff in terms of the enabling environment? That's where these ecosystems really propagate. When a lot of people do individual point solutions with different hardware, different software, you get this Frankenstein curriculum. Technically it's Frankenstein because they don't work together. Pedagogically, they often don't align. They're not providing the right type of feedback. And so where communities of practice can come together and really think about the ecosystem to create an enabling environment, I think we'll see more success.
I'm wondering if this is one of those technologies that will percolate from the bottom up, just as the PC did in corporations, just as BYOD, as they say in the enterprise world, right? Bring your own device. So I'm wondering if the parents are going to be the place where this starts.
I think they're probably going to be the place where it probably crosses the consumer threshold first.
I'm thinking in terms of especially parents of special needs kids.
Sure.
Autism, ADHD, and so forth. Do you think that's where this technology could gain a foothold?
Absolutely. I mean, I think there is already applications in the ADHD space. There are practitioners who are using neurofeedback and a closed loop neural system, again, in more of a clinical setting or a practitioner setting for that. And I think there's certainly, I mean, if you do a little bit of Google searching, right, you know that there are people who pitch to parents for that. And so I do think people do buy those systems. And there are probably more sophisticated systems that we as a community of practice could create. So
I think there's still so much more to learn. I mean, I normally also last year said, we got to go a little bit back to research stage, build the right methodologies, and take a multimodal approach on this. I mean, people who just do one thing or another thing, that's really not going to work. So I think all parents, for example, who have a sick kid, they will do whatever. They don't care if they're going high in their EEG on. I mean, if they can help my kid, that doesn't matter. So I think, what is happening right now is that now it's actually possible, like within the last year or two, to actually do these, and we talk about this closed loop system all the time, but maybe I should give an example for it so that everybody kind of know what it is. To give an example of how our system is applied in the US military, for example. So they want to test on soldiers the decisions they take under stress. So they build a virtual environment where it's basically a game you walk around in, and then you give some tasks to the soldier, and you can follow when the stress goes up. And a certain level, the stress is at a level where you really want to see, okay, what kind of decision does he take now? And then basically we shoot all that data into the virtual environment, and then it changes until he's there, and then bang, then it really gives him that task, and you see what happens. So I think we got to go back there and then take all the more high-end FDA-approved devices that are already proven, and then try to figure out what is it we really want to look for, and then we go backwards and we take all the more smaller devices and see can we get the same results out of combining some of them until one day we'll be more or less non-intrusive when all the technologies are strengthened enough. That's what it takes, I think, and then start in a place where, of course, you help people. For example, helping parents with kids that has ADHD or autism.
For us, our target market is absolutely the parents, because I mean our age group is K through 6 mathematics, right? So it's kids, and so what we want to do is demonstrate that this is an effective product, but we also have to make it fun for the kids to play. So my biggest challenge with my kids, in that age group, is to say, okay, play this educational game over your entertainment game, and it's 9 times out of 10, if you give them the choice, they're going to choose the entertainment game. So we work very hard to try to get, a very engaging narrative, high quality graphics, and give them that user experience. I mean, going through this, it's trying to create an entertainment game with 2 hands tied behind your back. We're trying to be socially responsible. We're trying to, incorporate education into that, and we're trying to incorporate the neuroscience behind it as well. So trying to hit all those marks is difficult, but we think it's possible, and we think we're a good way to getting there.
There's one other model that a lot of people overlook when they want to get into education, which is really the service model. And we're seeing this more and more with things like First Robotics, Project Lead the Way, where a lot of schools just don't have the resources or expertise. And so a provider comes in, often starting in the after-school environment and then into elective, and now it's bleeding into core curriculum, where they actually come with a service model, where you can come with an educator, you can come with physical gear and environments, and control the environment. And again, if it's a must-have, not a nice-to-have, and you're providing a full solution, and then you can train the trainers, and gradually over time, it can fold into the ecosystem. We have found when we're trying to do some things that are particularly innovative, or our technology is just not solid enough, we can come in with a service model. And I think in this space, that can be a very effective model.
Great point.
So does that get around the Frankenstein problem?
It gets around the Frankenstein problem within the scope of sequence of what you're providing. It doesn't necessarily connect with everything else cross curriculum. You know, over time that could happen, but it absolutely does, because you can control quality of service for that scope and sequence as to whatever you're engaged with.
Right.
Terrific. So what other stakeholders need to be convinced? I mean, we've talked about parents, we've talked about teachers, you've talked a little about selling at the school district level, which we said was, I'm guessing, kind of a frightening experience from the way you described it. Who else needs to be convinced for this to happen?
Well, to build on your comment about entertainment and education, which is kind of the essence of what we do as well, I'll tell you an audience that's often overlooked, which are tweens, teens, and young adults. There's lots of stuff for young kids. It's at the tween, teen, and young adult level, they're making their own purchases.
Yeah.
Or they're either heavy influencer or they're actually making it. And there's a very high bar if you want to rise above the noise and engage those. So, I mean, you know, we've been doing this for a bunch of years. We've only picked one project where we thought we had the talented team who've made hit games and could really, everything aligned to do that. But it's a tough bar. And often, you know, that's a cohort that a lot of people want to reach.
Right.
So it's a little bit complex. I mean, it's different in schools or after school if they're there. But to get the 8 hours that they spend on digital media outside of school is a really, really important challenge. And it's a priority for our company.
So aren't you really going against the Calls of Duty and the Sunset Overdrives and the various games that have budgets that are bigger than Avengers?
We are.
Yeah.
How do you do that?
Well, I mean, one example of a game that we just did, and I would say we're not competing on the AAA game space, but we're competing in the indie game space. And the indie game space is growing. I mean, the most successful game of all time at this point is Minecraft, which was made by an individual, and it disintermediated. It didn't have to go through a publisher, and 50 million kids are obsessed with it. So the indie game space, if you can rise above the noise and be differentiated, we just did a game with an Alaska Native tribal organization where we brought tribal elders, writers, and storytellers with some great game makers. The guy who led Tomb Raider, he created a number of hits for us at Activision. These are proven talent that really wanted to inspire kids around sharing, celebrating culture and why stories survive for 10,000 years. How could they survive for another 10,000 years? It's been successful. We've had 2 million downloads, we've won lots of awards, and we are competing against those games, but with a very differentiated offering. You know, sometimes you want to go see the Avengers and play Call of Duty, but sometimes you want meaningful, inspiring entertainment. We want to have that section and grow it.
That's a great game, by the way.
Thanks.
Yes, that's awesome. So, and we're talking about games and education, but do games have a stigma with, in terms of learning and education, or is that stigma specific to a particular generation of people?
I don't see that stigma as much anymore. I do think there's varying quality across the spectrum, and so that's important to to think about, like the first educational games and like I said, some of the casual things and things that are casually available. There really does need to be a differentiation from the quality, I think, that that folks in our space are developing versus that space. So I think there's not a stigma, but that's something to address.
I'm thinking the idea is, you shouldn't be playing a game, you're in school.
You know, it's interesting. There's great research at the Joan Gans Cooney Center at Sesame Workshop. It's the research arm of Sesame Workshop. They did a survey of the perception of games among a large number of teachers. And what was interesting is the teachers who most embrace game-based learning are the most experienced teachers. The ones that didn't grow up as digital natives, didn't grow up as gamers, but have a lot of confidence in their class management skills, want to engage their students. It was very much a surprise to all of us. So ultimately, teachers want what works.
Yeah.
And I actually think most of the games are poorly designed for the needs of a teacher, even if they have an alignment of engagement and pedagogy. Some do, some don't, varying qualities. Very few are effectively tuned for the needs of a classroom. So I actually think the problem is on our community. The ecosystem is the ecosystem. It's evolving, it's changing.
And I think the use of the term games is actually, it works in our favor, right? Because for our end user, it's the student, right? And so games is going to be more appealing to them. As long as we do our job of educating the people that are the decision makers for the type of content that they are using, then I think the game terminology works in our favor. And I think one of the challenges is to actually create. The game is the end result, like that's the surface level, but you need a whole lot of layers underneath that, which requires a lot of crosstalk and multidisciplinary approach to education, the neuroscience, and the gaming community to work seamlessly together to actually create an end product, which you can call a game, which has the end result of when the student is playing the game, that they're actually learning something, which is a challenge,
I think, so we've worked with a school district just outside of Denver, and we use their math teachers as our subject matter experts to help ensure that the curriculum was matching sort of the game mechanics and things that we had picked out. And they had gone to a standards-based sort of a mastery curriculum, so the students didn't really get grades, like A, B, C, D, kind of thing. They actually had to show mastery of particular topics, and then, so you could be a level 11 in math, but still a level 9 in English, and it sort of uncoupled that space. And what we saw was games enabled the teachers to behave more like guides rather than lecturers. And so I think that's a really interesting thing that games sort of provide, is the ability to kind of give a student a trajectory, like, hey, you're ready for this, let's go, take this, have this experience. We saw a lot of those teachers making their own content. Teachers would spend the summer making YouTube videos of math concepts with their dog and their husband, and that kind of thing. And games gave an opportunity to give these teachers who are now guides something to their students that excited their students but allowed them to kind of continue on that trajectory. So I think that's important too.
Well, like you said earlier, everyone likes to level up.
Yeah, exactly.
Right?
Exactly.
Well, you kind of get feedback from 4 different categories. So there's the system. The technology system can give you feedback, which is the sort of adaptive personalized systems, which works only to a point but can be very powerful. There's the teacher, who is the orchestrator, guide, blend, mentor. There are peers. Peer feedback is really important. And then there are various flavors of mentors, whether it's parents or whatnot.
Yep.
And the best systems will have a flexible blend, depending on the subject, the age, the context, of all of those feedback loops to help a learner on their journey.
Yeah.
Terrific. So we've talked a lot about classrooms and education. I want to step back and talk a little bit about commercial viability, because we talked earlier about possibly the parents will be maybe the primary market initially. What are the challenges in taking something that was strictly a medical technology and then in the research lab and now it's becoming commercial? What are the challenges in making it a viable commercial product?
So that's one of the things that we are facing currently. And in the decision to actually develop our game, we were very excited about VR technology, and we wanted to go down that route, but we realized we would have 2 hurdles to overcome. We have to overcome the schools actually purchasing this or the home user purchasing this, plus an EEG headset. So there's 2 pieces of equipment that they need to get. So we decided to go down the route of tablet devices, so iOS and Android and Windows platform tablets. And we had to make the design so that you could run it independently of the EEG, but the EEG is an added component that adds on an extra layer of functionality and improves the actual performance of it. So we had to be very practical in our approach. I mean, we're a small company, and we have to make that dollar stretch as far as we can possibly make it stretch. So, you know, the target market increases significantly if we go for the tablet market, and which schools already have devices, and they're looking for content to put on those devices. So that's now a hurdle that we don't have to overcome in having them buy a piece of equipment there.
Perfect.
I mean, if you're talking about games, you really need to understand the channels. So if you want to play in the consumer space, and you're not working just in the App Store, you need to understand the ecosystem around Valve and Steam, around Microsoft XBLA, PSN, the various digital stores, as well as the Apple Store and the Google Play Store. I can tell you just from quite a bit of experience that if you get the right placement and the right awareness in those stores, your sales dramatically go up. And there's an art and a science and a relationship to understanding how to manage those first parties. It's a little bit like at Activision when we would have to work with Walmart and Best Buy to get a box in a store.
Right.
That stuff matters. Obviously, you need to be differentiated to build awareness. In schools, you know, you can go bottoms up direct to teachers to a point. You can try to sell top down. Another way to look at it is to find people who already have a captive market. There are a lot of people who have a captive market who are in a lot of schools or after school programs, and they come from the paper publishing. They're looking for innovation. They're looking for innovative solutions. And if you don't have to solve the distribution and publishing problem, but you solve their innovation problem, you know, that's another way to you know, where 1 and 1 can make 3.
Yeah, we've actually distributed through like Brain Pop Junior, looking for distribution channels of things that already exist. So I think that's a very viable, rather than, you know, trying to tilt it all the windmills yourself. Trying to find a partner that can help you distribute is a big.
Brain Pop is great.
Yeah, I love Brain Pop.
I'm still waiting. I'm going to E3 in a month. I'm still waiting for them to do the big splash for the educational game instead of Call of Duty.
But we're pretty close. We're being featured at E3 this year, so with the Never Alone game. So
anybody can do it, Alan can.
So I think we have a few minutes. I have more questions, but I wanted to see if the audience has any more. Has any? There's a gentleman right there raising his hand. Second, third row.
Thank you.
Yeah, there'll be a mic eventually. We have the technology.
Thank you. I have, I don't know how to put this question. We heard a day before, 2 days before, about since you mentioned the magic word education, and we know that every brain is different. That's what we heard, and that's what we know. So I didn't hear from you that when you're selling, one of the challenges in a class is that a teacher, and from a parent point of view, has 20, 30 individuals, and they are all different, and the teacher says, I can barely get to 2 or 3 in the 45 minutes I have. So the magic word comes personalization, closing the loop. Where is the personalization in the educational game that will be a benefit that you can sell, a selling point to the educational system, that through your technology you're able to personalize, not only adaptive, but personalize through a profile, so every brain is unique and every brain learns in its own pace. So where is the personalization module aspect of what you're doing?
So one of the things, you know, for the individualization of the lesson is one of the things that is what separates us from the next typical education game. There's a lot of added functionality that we're able to derive from that, the neural feedback that we're able to then take, and we have, by creating everything under one roof, we embedded into the learning environment different ways to present that learning content. So the game adapts itself to the user so that every person's experience for going through a particular lesson, and we're following Common Core for K through 6 mathematics, every person's experience is going to be slightly different than the next person because every person's brain is different. At any given time during the day, your experience might be different. Your lesson might be slightly different because we have certain variables that we can control based on that dynamic feedback loop that controls those variables to optimize the content delivery to make it the most efficient mode of learning for that particular individual at that particular time. So that's the real promise of this technology. And we think we're there. We think we're, and we think the the future iterations of this, as we learn more, as we gather more data, the systems will become, quote unquote, smarter and smarter, the more normative data that we have to compare. So that, I think it's just going to improve from here. But the technology, the promise of this technology is exactly what you're talking about.
I'll play a little bit the devil's advocate. I think that's true to a point. I think these personalized adaptive systems, they're good in some subjects, less good in other subjects. They're fairly voracious in terms of the type of content one would need for truly adaptive learning systems. They are critical. They can create personalized learning. They can help the teacher become a conductor, an orchestra, a guide. But to me, the real secret sauce is understanding where they're effective, where they're not, and when they're not, how they can go into non-personalized adaptive systems seamlessly, so that the learning trajectory continues with other types of feedback, not just the technical system feedback. So I don't think this is a magic bullet. My colleague at ASU, Jim G, talks about, we have all these personalized adaptive systems for youth, but we don't live in a personalized adaptive world. And so it is critical, it is important. I'm a big believer in it, but to a point, and knowing what it does well and what it doesn't, I think is critical for our community. Terrific.
Thank you so much. We are out of time. This has been a great panel. I want everyone to give a round of applause. And if you have any other questions, please come up and ask us. Perfect.
Fantastic.